All right, let's get right into it. We're going to uncover the absolutely dramatic story of how our continents came to be. We're digging deep, way back into the planet's past, to figure out why the ground right under our feet is so incredibly old and, well, tough. So, let's kick things off with a number that might just blow your mind. You see, nearly two-thirds of our planet's surface, that's all of the oceanic crust, is, geologically speaking, basically brand new. The oldest bits of the ocean floor, they're only about 200 million years old. But, and this is the crazy part, compare that to the rocks on land. In places like the Canadian Shield or over in Western Australia, geologists have found rocks that are an unbelievable 4 billion years old. To put that in perspective, that's almost 90% of the age of the Earth itself. So right away, we have this huge paradox, right? It's the puzzle that really drives our whole story today. How can the continents be so ancient and durable while the entire ocean floor is constantly getting recycled? What's going on here? Well, the secret, it turns out, is all about the foundation. Unlike that constantly churning ocean floor, continents are built around these incredibly old, incredibly stable interiors. Think of it like a geological bedrock that just lasts. And this foundation has a name, of course. Geologists call it a craton. Honestly, the best way to think of it is as the continent's original indestructible seed, a piece of the planet's very first crust that has stubbornly refused to disappear for billions and billions of years. Okay, so a craton is the starting point, the seed. But that's just the beginning of the story. Continents don't just pop into existence fully formed. They grow over eons through a couple of really fascinating processes. So, how does a continent actually grow? Well, it happens in two main ways. On the one hand, you've got what's called magmatic addition. This is kind of like growth from the inside out. Magma wells up from the mantle and hardens, adding new mass from below. But then you also have continental accretion. This is all about adding to the edges. Little landmasses, think volcanic islands or even tiny continents, crash into the craton and get stitched onto the side. It's like adding patches to a giant geological quilt. Now, you know what happens when you have these giant land masses drifting around, right? Sooner or later, they're going to crash. And these collisions, well, they lead to some of the most dramatic, landscape-shaping events our planet has ever seen. And there's no better example of this than the formation of the Himalayas. So it all started about 50 million years ago. What is now the Indian subcontinent was just hurtling north towards Asia. As it got closer, it started to squeeze shut the ancient Tethys Sea that lay between them. Then, bam, the main event, the collision. We're talking about a monumental impact where the edges of these two continents just slammed into each other. The rock began to fold and fracture and buckle under just unimaginable strain. And here's the final act, the uplift. With all that pressure, there's nowhere for the rock to go but up. The crumpled land gets forced skyward, thickening the crust and creating these massive mountain ranges we see today. Just incredible. So, this whole epic process of mountains being born from these continental collisions, yeah, it's got a name. It's called orogeny. And it is the engine that has sculpted some of the most famous, most breathtaking landscapes on Earth. But here's the thing. This isn't a one-and-done deal. It's a cycle. A massive, planet-sized life cycle for continents that we call the Wilson cycle. It all starts when a continent rifts apart. As the pieces separate, a new ocean opens up. But eventually, that ocean starts to close again, pulling the continents back toward each other until they collide, creating a new mountain range, an orogen. And then, over millions of years, those mountains erode, and the whole thing can start all over again. All right, so for our last piece of the puzzle, let's tie this all together. To really get to the bottom of that original question, why do continents survive? We have to look deep, deep beneath our feet. Remember those ancient cratons we talked about? The indestructible seeds? Well, it turns out they have a secret weapon. They have this deep, strong root that goes hundreds of kilometers down into the mantle. Geologists call it a cratonic keel. And just like the keel on a ship, it keeps the continent stable, anchoring it and protecting it from being destroyed and recycled, like that flimsy oceanic crust. So why does any of this matter? Well, because this story, from cratons to keels to mountain ranges, it's the story of our world. These processes created the amazing landscapes we see. They've driven climate change and evolution for billions of years, and they continue to power the earthquakes and volcanoes that shape our planet right now. So I'll leave you with this question to think about. All this constant, violent recycling and clashing of crust is what makes Earth such a dynamic, living planet. But when you think about everything that comes with it, the earthquakes, the volcanoes, would you really have it any other way?